So now what we're going to do is we're going to try and compare ionization energies of different atoms. Okay, we're going to compare the ionization energy of this atom with this atom. I mean, previously we were not doing that. We were just removing electrons from a single atom. Okay, so ab jo hai na, that's so we're going to move towards comparison. And the first thing is what happens to, and they usually just talk about the comparison of the first ionization energy. Okay, so remember there are 5 factors. 3 of them are more important: protons, distance, and shielding. Achha, so the first part is comparison of first ionization energy down a group. And remember, we are only talking about the first. First ka matlab hai we're just trying to remove the first electron. So down a group. Achha, ispe what we have is, achha, let's say if I'm in group number 1. So group number 1, it's pretty obvious that the first atom has just 3 electrons. Okay, so that's the first and the second shell. That's it. The second atom in the group, in group 1, is going to have, it's going to be sodium, and sodium is going to have a total of 3 shells. So that's 1, 2, and 1, 2, and 3. Again, we're only talking about removing the first electron. So then after sodium, there's going to be potassium. So potassium is going to have even more shells. So it's going to be 1, 2, 288, 1 hota hai. So it's going to be 288. And there's going to be one more. So there's going to be one more shell. Okay, so that is what is going on. Okay, and remember, we are only trying to remove the first electron. Okay, let me label this. This is group 1. Okay, so this is group 1. This is lithium with 3 electrons. So 2 and 1. Okay, then you have sodium, which has 11 electrons. So it's 2, 8, and there's 1 electron in the outer shell. And then you've got potassium, which is going to be 2881. Okay, so you've got potassium, so that's 2, then 8, so then another 8, or finally in the end there's 1 electron, right? So by looking at the atoms, remember we're trying to remove 1 electron, just 1 electron. Is it going to be easier or difficult to remove this 1 electron down the group? What's going to happen down the group? Easier. So it's obviously going to become easier to remove electrons. That's why reactivity of metals increases down the group, because it becomes easier to remove electrons. So that means that the first ionization energy, it decreases down the group. It becomes down the group. It becomes easier to remove electrons. And then you would have to, give the reasons for that. So what are the reasons why the ionization energy is decreasing down the group?
Okay. So the shielding increases.
Shielding radius, so atomic radius increases. That's the first one. Atomic radii, they increase, the electron becomes further away. Plus, because of that thing, shielding also increases. So the electron is further and further away, so it's easier to remove electrons. So because of that attraction, I remember you always have to mention this in the exam when you're writing this, because of these 2 factors. Yeah, hence attraction between valence electrons and the nucleus decreases. between valence electrons and there's one factor that actually goes against this. What is that one factor? ये तो obvious है.
Increasing protons.
Increasing the number of protons, because remember potassium has more protons, right? So the electron should be more strongly attracted, but there are two factors that are actually going against it. This way you have to add that as well, that atomic radius, the electron is further away, plus the nucleus and the electrons, there are too many shells coming in the way, so the attraction decreases. So because of that, the attraction is decreasing, so it's easier to remove electrons. So there's only one factor that actually goes against this, and that is the वो mention करना है answer में. So despite the fact, so the attraction between valence electrons and nucleus decreases despite the fact that protons are increasing or nuclear charge is increasing. So nuclear charge increases. So you have to mention this one factor as well, which is going against it. Okay? So is this clear? That's about it. It becomes easier to remove electrons, and you just have to know the reasons why it becomes easier to remove electrons. Okay, clear?
Yes, sir.
So then, बाकी सारों को clear है. Saad, Zubiba, is this clear? Salah, clear है?
Sir, can you explain the last point again?
See, it's becoming easier to remove electrons, right? Why is it? It's becoming easier because the electron is further away. That means atomic radius. I mean, the atoms are becoming bigger, so it's easier to remove electrons, right? For shielding, too many electrons coming in the way, right? So there are actually two factors that support that it becomes easier to remove electrons. Again, down the group, the protons are increasing. Like lithium has 3 protons, potassium has 19 protons. So protons suggest that down the group, it should become harder to remove electrons. You have a point clear? Is that clear? That potassium has 19 protons, right? So this electron over here should be attracted more to the nucleus, and it should become harder to remove electrons. Lekin there's only one factor that actually supports that. Two of the factors, they suggest that it becomes easier to remove electrons. So इसका मतलब दो factors जो है ना वो कह रहे हैं कि it's going to be easier to get rid of electrons. And there's only one factor which is suggesting that it should be difficult to remove electrons. So the two factors that are mentioned above will outweigh the one factor that's mentioned at the end. So overall effect क्या होगा? It's going to be easier to remove electrons. Zubiba, do you get this point?
Yes, sir.
So, but when you answer this in your exam, you're gonna get a very typical question on this. So when you answer this in your exam, make sure you mention this point as well. That's the next one. The next one is across the period. What happens? So what happens to the first ionization energy across the period? Now we're not going down the group. And pretty much in any period, the trend is kind of exactly the same. So what happens across the period? So the first thing is, so let me draw some atoms. Okay, so you've got lithium. So all of them will have 2 shells. Let's say I'm talking about period number 2. So all of them have 2 shells, and there will be kitne atoms honge? There'll be, that's the first one, second. So there'll be 8 atoms in the second period. Okay, that's 5. So let's draw all of them. So you got 6 and 7 and 8. Okay, so let's go down. So those are all your atoms, right? Now lithium, the first one. Okay, if you know across the period, it's lithium, beryllium, boron, group 4, that's carbon, nitrogen, oxygen. So starting with the first one, it's going to have, so the first one is going to have 6 protons. Not 6 protons, it's going to have 3 protons. Okay, so the first element over here is going to have 3 protons and 3 electrons. The next one next door is going to have 4 protons and it's going to have 4 electrons. And so on. The next one is going to have 5 protons, it's going to have 5 electrons. Then you're going to have 6 protons, that's carbon. And you're going to have 6 electrons, then 7 protons, that's nitrogen. And you're going to have a total of 7. So you're going to have a total of 7 electrons. So 8 protons. And 9 electrons, that's 2 and 7, that's fluorine. Finally, at the end, it's going to be neon, which is 10 protons. And full electrons, outer shell electrons, that's 8 in the last one. So we've drawn all of them. As a first thing, across the period, remember we're moving across the period, so this is the entire period, from lithium to neon. Period number 2. Period number 3 may or 4 may, everything would be exactly the same. So we're moving across the period. And remember, we're only trying to remove the first electron from each atom. Just the outermost electron from each atom. I'm trying to remove this electron, the first electron from this one. We're just comparing the first ionization energy. So is it going to become harder or easier to remove electrons?
Difficult.
Okay, so the general trend is when you move across the period, it becomes ionization energies increase. Okay, which basically means that the attraction between the nucleus. So the attraction between the nucleus and valence electrons increases. And valence electrons, they increase. What are the factors? What's going on? Why does it become difficult to remove electrons? I mean, the first one, it's easy to remove electron. You get the first one. If you keep on moving to the right, it becomes gradually more difficult to remove electrons. So what are the factors involved? Why is it more difficult to remove electrons from this atom compared to the first one?
More protons.
More protons, right? So 3 protons, Joanna, they're not going to attract the electrons very strongly. But if you have 8 protons, right, the electrons will be very strongly held together. So the number one factor is you've got protons or nuclear charge increases. So protons or nuclear charge, it increases gradually from left to right. So that's why it's becoming harder to remove electrons. Neon ke case mein, it's got 9 protons. 9 protons will have a very strong attraction for electrons, right? The other one is, what about the other factors? What about shielding? Is there anything happening to shielding? Okay, remember, I'm trying to remove the first electron, the first one. Every time I'm removing it from the same shell, right? So the shielding is exactly the same. Okay, but if I remove this electron over here, then between the nucleus and this outer electron, there are two electrons. There's just one shell coming in the way, right? The same will happen even if I go further and I remove, if I remove the first electron. So between the nucleus over here and this outer electron, there's again just one shell coming in the way. Okay? So the shielding effect remains constant because they all have the same number of shells, right? You clear?
Yes, sir.
You're going to mention this, that shielding remains constant. Okay, so shielding effect is the same. So that's not a factor in this case. What about distance? What happens to the distance of the electron from the nucleus? उसमें कोई change आ रहा है कि नहीं आ रहा?
सर आ रहा है.
और किस तरह आ रहा है? Like in this
Sir,
case,
decrease हो रहा है.
Achha, and why does it decrease? I mean, this one, you're moving electrons from the second shell, right? Over here, you're removing electrons again from the second shell. So how does it decrease? Because all the atoms, they look kind of the same size. Same size? No, all of them are exactly the same size. So is the distance changing or not?
Sir, reasonably constant ही रहता है.
Reasonably constant रहता है, but there's a slight decrease. We did study this, that since the protons are increasing, what happens is that these three protons will not, they're not going to attract the electrons very strongly. So the electrons will be slightly further away. Okay, but when you move to the right, 9 protons or 10 protons, okay, they're going to attract the electrons very strongly. So the electrons will be a lot more tightly held together. So there's going to be a gradual or a slight decrease, just a very slight decrease across the, when you move across the period. इसको थोड़ा सा exaggerate कर लेते हैं थोड़ा सा, just a second. अच्छा, we did study this, so you thought. So when you're moving across the period, you've got more protons. More protons means more attraction for electrons. We did this somewhere above, ये वाला part. ठीक है, I told you that ये वाला था actually. When you move across the period, the atomic radius, it slightly decreases as you move to the right. It's not a major decrease, just a slight decrease. More protons, the shells are the same, so there's more attraction. So the third factor that's also playing a small role, which is that the atomic radius slightly decreases as you move to across the period. So that also indicates that it would be harder to remove electrons, because if the atom is smaller in size, if it's smaller in size, there's going to be stronger attraction. Those electrons are further away. So when they ask about the general trend, the ionization energy increases mainly because of more protons. Okay, main factor jo hai, that's obviously as a main factor is more protons, right? That's the main factor. Or Baki shielding is not a factor, but the atomic radius gradually decreases across the period. Ye clear? Is this clear across the period?
जी सर.
Baki clear? Salal clear? Zaviba, is this clear?
Yes.
Salal?
जी सर.
Yes, sir.
So I'm going to sketch this now. Okay, on a. Now that's the general trend. Remember that. Okay, so I'm going to sketch this. So this is ionization energies and just the first ionization energy across the period. So this is first. So just the first ionization energy. और इसमें ये कि so I've got lithium, beryllium, boron, carbon, nitrogen, then oxygen, fluorine, and neon. Okay, that's across the period. And let me label them. That's Li, B, C, N, O, F. And the last one is neon. And this axis is the first ionization energy. So what's going to happen? The general trend is that it should increase. It should just go up, right? But what happens is that it doesn't directly go up. This is what it actually looks like. That the first one is the lowest, then beryllium, it increases. Then at boron, it slightly dips. Then you've got carbon, then nitrogen increases again. Then there is a slight dip at oxygen again. And then you've got fluorine, and then you've got neon, last neon. Okay. So it's not a straight line going up. It's got two dips. So generally we can say, generally we can say that it is going up, right? So the general trend is fine. You can talk about it. So that's the general trend. But remember, it's not a straight line. And the graph will be exactly the same for all periods. Every period will have, when you move across the period, you've got more protons, right? So, but there's going to be a dip at boron and there's going to be a dip at oxygen. Basically, the dip is at group 3. And you got one dip at group 6. Okay, so something happens at group 3, which is why the ionization energy, instead of going up, it actually decreases. When we talked about the factors, I told you that the ionization energy increases across the period, right? Because every time you got more protons, so it becomes harder to remove electrons. But always there's a dip at group 3 and group 6. And the question, you get a question very often, and they ask you to write an explanation why there's a dip at group 3. Okay, so you always get an explanation. Well, I mean, you have to explain this. So the answer to this is that, remember, I talked about 5 factors. I talked about the 5th factor, which was orbital and subshells. And I told you that's not a big factor. I told you that you've got all these factors: nuclear charge and atomic radius and shielding and the net positive charge on the ion, right? But then I told you about subshells and orbital arrangement, and I told you that's not a major factor, but it matters in a few instances. And those instances are group 3 and those instances are group 3 and group 6. Like what happens, what goes wrong over there? So something happens. Boron should have had a higher ionization energy, but instead it's not following the pattern. The ionization energy suddenly drops. So what changes when you're at beryllium, and what happens when you move towards boron? So what happens is that the orbital arrangement changes. Like if you're at group 2, and group 2 was beryllium. Now beryllium has 4 electrons, so the electronic configuration is 1s2 and 2s2. But when you move to the next element across the period, you move to group 3, and group 3 is boron, right? Boron's electronic configuration is, it's got 5 electrons, so it's 1s2, 2s2, and 2p1. So what happens at boron is, why is boron decreasing? In boron, the electron is removed from a p orbital that's slightly further away. Okay, beryllium had fewer subshells. I mean, they were closer to the nucleus, but boron's case, the electron is being removed from a slightly higher energy p subshell, which is why it kind of becomes easier to remove this electron. Usually you don't talk about subshells, right? But over here you're going to talk about subshells that it's got one extra subshell. So less energy is needed because it's slightly further away. ये बात clear है? Is this clear?
Yes, sir.
ठीक है, it's the same thing. It's just that there's one extra subshell, and that subshell is slightly further away because it's and it's got more. It's more shielded as well because it's got more inner subshells. So just over here, there's a very slight dip. It becomes very slightly easier to remove this electron compared to the 2s electron. The 2s will be slightly more difficult because there are fewer subshells. The nucleus will strongly attract them. ये थोड़ा सा दूर हो जाएगा, ठीक है? It will be slightly further away. So the answer that you're going to write for, and it's a very typical question every time it comes, the answer that you're going to write about this is that the first thing is, it's just going to be a 2-3 mark question. The first thing you're going to write or mention is that in boron, electron is removed from a higher energy p subshell which is more shielded or has higher shielding compared to the other atom, which is boron's 2s subshell. Boron mein electron will be removed from a slightly closer. Let's give a marker. As a boron mein electron is going to be removed from a slightly closer 2s subshell. So, which is more shielded compared to beryllium's 2s subshell. So there's वो भी लिख लो attraction की. So there's hence slightly less attraction between boron's nucleus and outer valence electrons. Because that's why it slightly becomes easier to actually remove this electron. Is this clear to everyone?
Yes, sir.
So anyways, there's going to be a question like, why wasn't subshell an issue between lithium and beryllium? Because they had the same subshell. Like if you write the electronic configuration, if I write the electronic configuration of, why did it happen at boron? Because usse pehle the subshells were exactly the same. Like lithium is going to be 1s2 and 2s1. Beryllium is going to be 1s2 and 2s2. So electrons are being removed from exactly the same subshell, right? It's only at group 3 that the subshell becomes, okay, it's got 5 electrons, so it becomes 2p1 as well. So the electron is slightly further away. Then after this, the subshell is not an issue because carbon has the same subshells as boron. Okay, it's only जब यहाँ से यहाँ move करो ना from beryllium to boron, that's when the electron starts getting removed from a slightly higher subshell. Now carbon will have exactly the same subshell, so subshell is not a factor. So carbon is going to follow the trend. The trend is not going to get disturbed by carbon or by nitrogen because they're going to have exactly the same subshells. वो लिख लेता हूँ इसके नीचे. It's this one will be, carbon will be 1s2, 2s2 and 2p2. So they have an identical subshell, so that's not a factor. Nitrogen is going to be 1s2, 2s2 and 2p3. Now after 2p3, when you reach oxygen is going to have 8 electrons. So it's going to be 1s2, 2s2 and 2p4. So if you look over here, there's a dip at oxygen now. So what happens after nitrogen that it slightly becomes easier to remove electrons from oxygen? Okay, so we're gonna discuss that, like what goes wrong with oxygen. तो oxygen के case में ना, this is what happens. Now, before oxygen, nitrogen electrons were being removed from nitrogen. Nitrogen had an electronic configuration of 1s2, 2s2, and 2p3. 2p3 means that the 2px, 2py, and the 2pz had 1 electron each, right? 7 electrons. When you move to oxygen, which had 8 electrons, then in oxygen case, it's 1s2, 2s2, and it's going to be 2p4. That means, so now 2p4 means 2px, 2py, and 2pz. So each one will be filled first, and then one of them will have 2 electrons. So the question is, the subshells are identical, they're exactly the same. So why is it becoming easier to remove electrons from oxygen? What's the difference between the, like, why does it become easier to remove electrons from oxygen?
Plane pair repulsion between the electrons in px orbital.
Okay, because if you look over here, each of the p orbitals had 1 electron. Okay, this is what a p orbital looks like. If I draw or sketch the p orbital, this is the center is the nucleus, right? And these are the 3 axes. So in nitrogen's case, all of them had 1 electron each. So all these regions had just 1 electron moving around, and they were all occupying different regions, right? So they were not repelling each other. So there was 1 electron that was buzzing over here. There was 1 electron that was so there was 1 electron and its negative charge in this area, and then you had another electron and its negative charge was spread in this area, right? So every electron, 2px, 2py, 2pz, they had separate areas, right? But now you've got 2px2, which means that one of these orbitals, they don't have a single electron. One of them has 2 electrons. So I'm just going to write, so one of the orbitals is going to have 2 electrons. So now imagine if there are 2 electrons occupying the same orbital, although the maximum number of electrons allowed in an orbital, it's 2. The 2 electrons will be repelling each other. So the electrons, like if 1 electron is on this side, the other electron will be trying to so both electrons will be trying to knock each other out. So there's 1 electron that's moving in this area, and there's another electron, and they're both trying to repel each other, right? So if you have 2 electrons in the same orbital, like you do over here, okay, so the electrons are going to repel, the 2 electrons are going to repel each other, which is why it would kind of become easier to remove electrons. Is this clear?
जी सर.
ठीक है, एक दफा फिर मैं repeat कर रहा हूँ कि in nitrogen's case 2px, 2py, 2pz. So that means the nucleus, 1 electron over here, 1 electron on the z-axis, 1 electron on the x-axis, right? And so they were all in separate orbitals and they had nothing to do with each other. यहाँ पे ये हुआ है कि you've got one of the orbitals is now having 2 electrons. So if let's assume this is the x-axis. So if on the x-axis the same orbital has 2 electrons now, the 2 electrons will try to knock each other out. They will try to repel each other. So it will become very hard to keep 2 electrons in the same orbital, which is why it would kind of become easier to remove electrons. ठीक है? तो clear है, ये बात clear है सारों को?
जी सर.
Yes, sir.
So, and that's known as spin pair repulsion, or electron. You can simply say that there are 2 electrons in the same orbital, and the electrons, they repel each other. So इसकी explanation ही होगी. And remember, the wording has to be very exact. Remember, it's not English. You can't just use your own words. You have to answer questions technically, right? I mean, there's no other way of, and you have to be very brief. Like previous question, when it was electrons moved from a high energy p subshell, this is what you're going to write exactly. You just can't restate it in some other word. I mean, but वो SSD लिखने, ठीक है? You have to be very brief. So this one, the answer to this would be that in oxygen, electron is removed from a paired p orbital. as a from a paired p orbital. And so while in the other one, while in nitrogen, the electron is removed from a half-filled p orbital. It gets removed from a half-filled p orbital. So due to spin pair repulsion in oxygen, spin pair means you've got a pair of electrons, right? So due to spin pair repulsion, it is easier to remove electrons from oxygen. ठीक है, तो simple answer is वहाँ पे there was only one every orbital had one electron. Over here the p orbital had 2 electrons, so it's easier to remove an electron from this one because you've got spin pair repulsion, or you can write an electron repulsion. ठीक है, is this clear?
जी सर.
और इसको इन दोनों को ना make sure you remember this, both of these, and this will happen for every period. So across the period, you just have to remember the first thing is the general trend is you're moving across the period, you got more protons. Okay, so it's harder to remove electrons. The shielding is the same, and the distance slightly decreases, very slightly, which is why it becomes harder to remove electrons. So the general trend is going up across the period, but there's going to be a dip at group 3, and there's going to be a dip at group 6. अच्छा, एक तो ये इसको बस sum up कर लेते हैं. So I'll just put a sketch of ionization. अच्छा, एक sketch में दिखाना कि I guess this one. So let's just copy this, put it over there. So यहाँ पे दिखा देता हूँ, there's something wrong right now. अच्छा, this one. These are the trends across the period. These are consecutive proton numbers. ठीक है, 1, 2, 3, 4, 5, 6, 4. It's the entire periodic table. The first period has just hydrogen and helium. So hydrogen has a lower ionization energy, helium has a higher ionization energy. This is the second period. This is lithium, beryllium, boron pe dip hai, then carbon, nitrogen, oxygen, there's a dip, then fluorine and neon, right? That's across the period. Then you move to the next period. Now remember, every time you're moving, what are you doing? You're moving down. Every time you're moving one step down. Next period, it's going to have more shielding. There's going to be more shells. So this is the next period. So the next period will have lower ionization energy compared to the previous one. It's going to be the exact same trend. Period number 3. This is period number 3. It's going to have exactly the same trend. Here, group 1, group 2. There's a dip on group 3, 4, 5, dip at 6, 7, and 8. So across the period, the trend is exactly the same every time you move across the period. Ye kya cheez hai? What does anyone know what this is?
Transition metals.
Okay, these are transition metals, because if you look at the periodic table, let me just open the periodic table. So I'm just going to try and explain to you. not every period has exactly the same number of elements. As I look away, first one just 2. So hydrogen will have lesser, helium will have higher. But every time when you move to the next period, the ionization energies will decrease. Down the group decrease hoti hai, theek hai? So lithium, beryllium dip at boron, then carbon, nitrogen dip at group 6, then fluorine and neon, right? Then you move to the next one. Sodium, magnesium dip at aluminium, then silicon, phosphorus, then sulfur, it's going to go down, then chlorine and argon. But when you move to the 4th period, there's going to be 10 in the middle, there are 10 transition metals as well. Now, transition metals, their ionization energies, the first ionization energy hardly changes. You're going to study that in A2, okay? You're not going to study that right now. Just don't get confused, okay? In period number 4, instead of 8 elements, you're going to have these 10 extra transition metals as well. So when you look at this image, the sketch is exact. I mean, if you ignore the transition metals in the middle, the trend kind of looks exactly the same. It's dip at group 3, then dip at group 6, then 7 and 8, right? So if you just ignore the 10 transition metals in the middle, okay, this is group 1. I think this is group 2. I guess this is 3. So there's going to be a dip over here. 4, 5, 6, but there's a dip, 7 and 8, right? So ignoring these, otherwise it's exactly the same. Then you have next period, you again have transition metals. Next one, you again have transition metals. So transition metals, the first ionization energy hardly changes. So we'll just focus on the first 2-3 periods. Okay. लेकिन इसका ख्याल रखना है कि what happens, you'll get a lot of questions on this, that you'll be asked to tell what the group is. I mean, they might ask you which group is this? This is noble gases. Like this is group 1, 2, dip at 3, 4, 5. This is 6. This is group 7. This is group 8 or noble gases. So that's the general sketch. Okay, clear? Next class में past papers करेंगे. We're done with the chapter. We're done with atomic structure. कोई question तो नहीं है, confusion तो नहीं है?
No, sir.
चलो ठीक है, ये फिर ना इसके past papers we'll do that in the next class then, ठीक है?
Okay, sir.
Okay, everyone, take care.
Love you, sir.
मैं अभी देखता हूँ बोर्ड का, मैं देखता हूँ क्या मसला है, चले मैं करता हूँ.